welcome back to the channel. Today we are diving deep into one of the most powerful feature of TensorFlow, the subclassing API. So if you want more control over your model's architecture, or if you are building a complex model that require custom behavior, this is the video for you. So let's jump right into it. So TensorFlow by default offer a high-level API like sequential or the tf.keras.Model to build the deep learning models. These are great for many cases, but what if you want something more custom, such as defining your own layer, forward pass, or training loop? That's where the subclassing API comes into play. So instead of relying on pre-built layers and models, you can subclass tf.keras model to create your own model class. This gives you complete flexibility to define custom behavior for your own architecture and training process. So subclassing is essential when you create a new class that inherit from an existing class like tf keras model and override its method to define your own custom logic. Now let's break this down with some code. So here's a basic example of how subclassing work in TensorFlow. Let's start with simple neural network that subclasses tf keras.Model. So let me import the TensorFlow. So in this example, let me run this cell. So in this example, we are defining a simple neural network with two hidden layers and output layer. Here's what's happening. So underscore underscore init method. In this method, we define the layer of our model. We use tf keras layers.tens to add fully connected layers to our model. And this call method, so this is the most important method to override. It defines the forward pass logic, which is how data flow through networks. We specify the order in which layer are applied to the input X. So next is initiating and using the model. So now let's see how we can create an instance of this model and use it for training and interface. So let me run this cell. So we have created a batch of 32 samples, each with 784 features, which could represent flattened 28 multiplied by 28 images like MNIST. When we pass this input through this model, it outputs a batch of 32 samples with 10 class probabilities, as expected for classification tasks. So next is the important part, the custom training loop. So if I run this, so this is one of the biggest advantage of subclassing is that it allows you to define a custom training loop. So TensorFlow offer automatic training loop via model.fit. And but if you need more control over the process, subclassing give you the flexibility to do just that. And let's train our model. So here we define the custom training step with TensorFlow gradient tape. And so in this gradient tape inside the training step function, we record the forward pass using tape.watch function, calculate the loss using loss function, and compute the gradient of the model trainable variable with respect to the loss, and apply the gradient to the output the model weights. So tf dot function is a decorator is used to optimize the function for performance. Next, let's put all this together and create a custom training loop, which I just already ran. So in this loop, we load the MNIST dataset and normalize the images. Next, we use a tf.data.dataset to handle patching and shuffling of the data. Third, for each patch of the image and label, we call our custom train step function and print the loss after each patch. So as you can see, so the loss is getting printed after each patch. So why should you use subclassing? Here are the main benefit. First is flexibility. You can define custom layers, loss function, and even the entire training process. So this is essential for complex models. Next is control. You get to control the data flow and training loop, which is ideal for research or unconventional architectures. Third is the custom layers. Subclassing allow you to implement your own layer or modify existing one. That said, subclassing is a bit more verbose and require you to manage more of the training process yourself. So it's not always necessary for a simple mode. All right. So that's a wrap for today's deep dive into TensorFlow subclassing API. We have learned how to subclass tf.keras.Model, define custom layer, and even implement a custom training loop. So this level of control is perfect for advanced deep learning projects where the standard model.fit isn't enough. I hope you found this useful and feel empowered to experiment with the custom architecture. Thank you for watching. I will see you in the next.